This is R.D. Sharma Solution Class 12. Chapter 18 we are taking Maxima and Minima. Exercise is 18.5. Of all the closed cylindrical cans, write circular, which enclose a given volume of 100 cm cube, which has the minimum surface area. Now what you see here is, we are talking about a cylinder which is a right circular cylinder. What is the volume of the cylinder, which is already given in the question? 100 cm cube. This is the radius, this is the height. If we take any right circular cylinder, now what is the volume? It is pi r square h, pi into radius square into height. And this is given as 100, so we'll equate it with 100. Height will be 100 divided by pi r square. This is height. Now coming to the surface area, minimum surface area, talking about surface area. Surface area is the whole, this area, this is outer area or a curved surface area, plus the surface area of both the ends, which is pi r square plus pi r square, 2 pi r square plus 2 pi r h. Now surface area we can write it as 2 pi r square plus 2 pi r into h. And what is h here? 100 divided by pi r square. Now what do you see here is 2 pi r square. Now you just cancel this, you will get 200 by r in this case. Now the second thing is to differentiate this, because we are intending to find out the minimum and maximum of surface area. So surface area needs to be differentiated. I am going to differentiate it right now. 2 pi r square plus 200 by r. 2 pi r square is 4 pi r minus 200 by r square. This ds by dr has to be equated to 0. So ds by dr equated to 0, we get 4 pi r equals to 200 by r square. When we take this, this is going to be r cube. R cube is equal to 200 by 4 pi. We are getting r cube equals to 200 by 4 pi. So r will be simply equal to 4 pi divided by, or 200 divided by 4 pi to the power 1 by 3. Now you can just cancel this 4 with 200, you will get 50 by pi, and this goes to the power 1 by 3. This is the radius, and this is the final answer I am telling you. But we will not stop here, because we have to say that it is minimum also. For that we need double differentiation. We are differentiating this expression again, 4 pi, and here we will get r cube. So it will be minus will be plus 200 by r cube, and this is going to be 400 it will be. Now what do you see here? Radius cannot be negative, so this whole will be positive. This whole expression is positive. So d2s by dx2 is actually greater than 0. So you are going to get a minimum surface area, because we have verified that it is going to give us the minimum value. What is the radius? It's 50 by pi to the power 1 by 3. This is your answer also. But once we are at a radius, we need to find out the height also. Height is 100 by pi r square. And this r square goes to 50 by pi to the power 1 by 3. 1 by 3 into 2 is 2 by 3. Now this 100 by pi can be written as 50 by pi, that is 2 into 50 by pi. When you have 2 into 50 by pi, this 50 by pi in the denominator goes up, which is minus 2 by 3. So 1 minus 2 by 3. Let me show you what I am trying to say. 2 into 50 by pi, 50 to the power 1. 50 by pi, this goes up, minus 2 by 3. 1 minus 2 by 3 is 3 minus 2 by 3, that is 1 by 3. So what do you get? 2 into 50 by pi raised 1 by 3. This gives you the height also. We have the radius also and the height also. So this is the reference for you, and all the language we need to follow from here. A beam is supported at the two ends and is uniformly loaded. The bending moment m at a distance of x from one end is given by this one. Find the point at which m is maximum in a given case. Now the next question also is exactly like this, so you have to follow this diagram very carefully. This is a beam, and the beam is also supported, and the load is uniformly balanced. And you don't have to go into the basics of the physics which is being provided here. We have to stick with our minima and maxima kind of thing. What we are actually going upon. If this part, one of the part is x, the next part will be simply the distance minus x. But we don't know the total distance, you can call it as L. So L is the length of this beam, which is given in the question also. And W you can call it as weight. M is the moment, bending moment. Moment is one kind of force. It's kind of force. So already M equals to WL by 2x minus W by 2x square is given. We will simply differentiate it. And when we differentiate it, we'll put it as 0. That is the first step we generally follow. We have WL by 2x already differentiated. W by 2x square will be 2x. 2 gets cancelled. WL by 2 minus W into x. This is our differentiated value. Now the second step after differentiation is to equate this to 0 in order to get the relationship between x and L. X is what we have seen from the question, L is also from the question only. So there is a relationship between them, and we have to tell the relationship or the value of the x, which is in terms of L, which is L by 2. X is L by 2 in this case, that is the total length divided by 2, that is the half of the length. So we have talked about the half of the length. X is L by 2. Now we have to also show that M is maximum. We need to differentiate it again. dm by dx has to be differentiated again. WL by 2 will be 0, minus W only will come. Negative means W cannot be 0, but it is a force. And say weight cannot be negative, it is negative, that is you are going to get a maximum value, and maximum is going to come and at x equals to L by 2. This is the complete solution in front of you. All the English sentences you have to follow from here, and the logic I already provided to you. You can just follow that logic. This question also involves the same logic. There is no difference, only the difference is in the expression. Previously the expression was in square, this we have the expression in cube. So we'll get a slightly different value of x and L, that is we are going to find out the value of x which is pertaining to L. Now dm by dx we have to do, that is the differentiation of this expression. Once you differentiate this expression, you are going to get this. This is not x, I am just cancelling it. Wx by 3, when we differentiate it is going to be w by 3, and this is minus w by 3, and this x cube will be 3x square. You get 3x square. L square remain the same in the denominator. This 3 gets cancelled. You get w by 3 minus wx square by L square. Please remember this w is in the capital letters. And we need to equate it to 0, that is our next step. dm by dx is equal to 0. When we equate it to 0, we'll get a relationship between L and x. So L and x, what do you get here? This gets cancelled. X square equals to L square by 3. X is equal to L by root 3. That is, x square is equal to L square by 3, and we have taken under root on both the sides. It will give us L by 3. This L by 3 is the value of x, and this is the answer, L by root 3. But we don't have to stop here. We can stop here, but the question is also asking about maximizing the m. So d2m by dx2 we are doing. Already the expression is in front of you of single differentiation. The double differentiation, w by 3 is going to be 0. This minus wl square will remain like this. X square will give you 2x. So all this right hand side is positive, the left part which is negative. All those right part will always be positive. So this is negative in entire case. So this is going to give you maximum. This is the value of the maximum at x equals to L by 3. All the English sentences you have to follow. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and other into a circle. What should be the length of two pieces so that the combined area of the circle and the square is minimum? Again, there is a question coming exactly like this. You need to follow this question very carefully. If one part we have taken as x, the other part will be of course 28 minus x, because we know that x plus y is 28. If we take 1 as x, y will be 28 minus x. So x and y we generally take, one is x, one is 28 minus x. Now the second part is that this whole piece will be made as a square, and the remaining piece, which is 28 minus x in the case, will be made as a circle. And what is the side of one, because square has all the equal side. So when we add the four sides, you are going to get the x. That is the perimeter of this square is actually equivalent to x. Side plus side plus side plus side. So 4 into side is equal to x, because this x will be made into a square. So 4 into side is equal to x. That means the side is equal to x by 4. We are not interested in any other thing. We are interested in anything which is pertaining to x, which we have imagined or which we have guessed. What is the circle? Circle area is pi r square. Area of a circle is pi r square. You already know what is the pi r square, but before that we need to talk about the area of square, because we are talking about area of square. Area of square is just side square, and side is already x by 4, which we have just seen. So side square is x by 4 whole square. It is going to be x square by 4 4 is 16. X square by 16 it will be. This is the area of circle, area of square. Now coming to the area of circle, which is going to be pi r square. Now we are interested in the radius of this circle. Radius of the circle is computed by the perimeter of the circle, because 28 minus x is going to be formed as a periphery of the circle, or the circle will be formed only by that 28 minus x, that kind of piece. So 28 minus x is the perimeter of the circle, and circle perimeter is simply 2 pi r. From here you are going to get r in terms of x. R is simply 28 minus x divided by 2 pi. So in order to find out the area of the circle, pi into r square is pi into 2 and 28 minus x by 2 pi whole square. So this is 28 minus x 2 pi whole square. When you square this, what do you get? And 1 pi will be cancelled. I'll just show you I'm going to show it to you that we'll just deal with 1 pi. Now the complete area is simply the area of the circle plus area of the square. These two areas have to be combined, and this has to be said that this is minimum. So let me just combine these two and add these two. So the one will be x square by 16 because 4 4 is 16. 28 minus x whole square by 2 pi square, and pi is already there. So there is pi and 1 pi gets cancelled. So it will be simply 28 minus x square by 4 pi. 1 pi is there, and I told you that area of circle, if you see closely, there is 2 pi square in the denominator. 4 pi square will come and 1 pi will get cancelled. So ultimately what we got is x square by 16 plus 28 minus x whole square divided by 4 pi. Once we have this, we can just add them. Or the best thing is, rather than dealing with the square and adding it and forming an expression, better way is to actually differentiate it. So we are going to differentiate this expression, and this expression, single differentiation, the double differentiation, we have to prove that it is going to come as positive so that it can be minimum. So again, coming back to this expression which we were talking about, let us call it as z. You can call it as any variable which you want. But when we have taken x and y, the other will be z, of course. This is the trivial traditional thing we follow. Now I am differentiating, as I said, 4 pi will be in the denominator. X square is 2x, 2x by 16 is x by 2x by 16 is x by 8. 28 minus x, 2 into 28 minus x, and 28 minus x differentiation is negative. So we have just placed a negative in between. 4 pi is in the denominator. Now just equate it to 0. When we equate it to 0, this left hand side and right hand side, these two terms will go on left and right, and you have to just find out and rearrange it so that you get x. I hope you will be able to get the x from here, because this is not a very big task. The whole idea is to differentiate, equate it to 0, and try to find out the value of x, which will be the final answer. And you don't have to worry about the answer, because ultimately we have to show by the double differentiation that it is going to be minimum. So I'm just trying to find out the value of x that will be fed to y, because y has to be computed. That is going to be 28 minus the value which is formed here. So let me write the final value here. I hope you are able to understand these all concept. The only resolution after simplification, the final value we are going to get, x is equal to 112 divided by pi plus 4, and y can be computed by 28 minus x. 28 minus 112 by pi plus 4. That will be your y value. So this is how we get the x and y value. I hope this is quite clear to you. X and y value we have come across and we have found it. Now this x and y can be computed easily. The next step is to differentiate again. So I am differentiating it again. d2z by dx2. Already you know what we have got when we did the first differentiation. If you remember that thing, or if you are writing it right now, then you can just differentiate it, and you just have to prove that it is going to be minimum, because it is greater than 0. So just see that it is going to be greater than 0 or not. This is the first differentiation which already being completed. We are going to differentiate it again. 1 by 8 minus this 2 goes here, 1 by 2 pi. This is going to be negative, negative to negative, negative becomes positive. So we have 1 by 8 plus 1 by 2 pi, and evidently by visual inspection also this gives you greater than 0, that is positive, that is minimum only. So what was x? If you remember, it was 112 by pi plus 4. And in order to get y, it's simply 28 minus 112 by pi plus 4, as I indicated earlier also. And these are the final values which you can write. And this has come from all the discussion which we had when we started with circle and square area combination. So these are the length of the two pieces which will give you the combined area as a minimum for circle and square. So this is the whole solution or the reference which you can follow in order to solve this question. And there are certain languages which you need to write that are mandatory for examiner to know that you know this question, how to solve it. Next one is again almost equal to the similar question, previous one. A wire of length is 20 here. We have to cut it into two pieces, one into square and one into equilateral triangle. So there is a change from the previous question. Previously it was square and circle. This is square and equilateral triangle. And area of the square and triangle is to be minimum. So same on the line of the previous question, we will do the same thing. We have 1 as 20. If we take 1 as x, the other part will be 20 minus x. And same thing we have to do here also. X is the whole addition of the four sides. All the four sides are equal, so you can call it as 4 into side is equal to the perimeter. What is the perimeter? After all, this part is going to be bent in order to form a square. So when you make a square with this length, 4 into side is going to be equal to x. So side is simply equal to x by 4. That is 1/4 of x. That is a simple and very common sense discussion, that if 4 sides are being made or 4 parts have to be made equally of x, it will be x by 4. So area of this square will be x by 4 whole square, that is the side square. X square by 16 is the first part we have done. The second part is for triangle, which is the equilateral triangle. Now this 20 minus x is the whole length, and this whole length will be formed into this form of triangle, and this triangle will ultimately tell you that it's going to be the area of the equilateral triangle. Before that we have to find out the side. For finding out that side, we have to use the formula of the equilateral triangle perimeter. The perimeter, that means the 3 into side. All the sides of the equilateral triangle are equal. When all the sides of the equilateral triangle equal, that is 3 into side is equal to the 20 minus x. This area root 3 by 4 by sides into side square we are going to use just now. But basically 3 into side of our equilateral triangle, of an equilateral triangle, is 20 minus x. So this side will give you 20x minus 3. 20 minus x divided by 3. Area of equilateral triangle is simply root 3 by 4 into side square. Root 3 by 4 into side is 20 minus x divided by 3. So you have 20 minus x divided by 3 whole square. Okay. Now the next part is we have to take them combined in a combined way. So when we combine the square and triangle, the z will be equal to area of the square plus area of the equilateral triangle. When we add this, x square by 16 plus root 3 by 4 and 20 minus x by 3 whole square. And rather than actually going for 20 minus x square as a minus b whole square, we will simply differentiate it here only. Differentiating here will be quite simpler, because x square by 16 will be 2x by 16, which will give you x by 8. Here in this case you have root 3 by 36. Let it be like this. 20 minus x square will be 2 into 20 minus x. Differentiation of 20 minus x will be negative 1. So this negative will come in between. This is not positive. Actually positive was already there. This will be negative in between. So we will get x by 8 minus 2 root 3 by 36 into 20 minus x. So there will be a negative in between. Now the next step is to, for minimum, maximum, or whichever way you want, it has to be equated to 0 in order to get the critical point, because that is the critical point, and that is the critical point which is the length of the wire here. So just equate this to 0. The left hand side and right hand side will come on the LHS and RHS, and from here you need to find out x. I hope you'll be able to find out the x, because this is simple simplification of the numbers which are given here. 2 into 18 is this, and 4, and this is going to be 9. So rather than, there is one more thing, root 3 is also there. So I'm computing it, but rather than computing, I will definitely leave it for you, because this kind of simple things I understand that you guys are quite well versed with, because you are in the 12th standard. Until 11th standard you have learned all these things, and you are well versed and well capable of solving these kind of simple expressions. So let me write the actual expression here. That expression is going to come like this. X is equal to, this is the x value and this is the final value. The y value will be 20 minus x. 20 minus of this value, that is 80 root 3 divided by 9 plus 4 root 3 is going to come as x, and 20 minus of this value will be the other value, which is y. These are the two parts. But we are not done here, because we need to differentiate it, and then we have to put it as negative or positive. We have to regard it as negative and positive. d2z by dx2. And the original expression, if you remember, was 2x divided by 16, and this is simply x by 8 minus 2 root 3 and 20 minus x divided by 36. So double differentiation will give you 1 by 8. This is going to be 20 minus x will give you negative. So I have already placed a plus here, 2 root 3, and this is going to be 36 in the denominator. Okay, so now this has no x, and you can just simply get the number, and number can be positive or negative. And this is positive because you can see all the numbers are positive. And once the positive number has been received, or we got the positive number, we can easily declare that this expression is actually going to give us the minimum value. This value indicates that the expression from where we started will actually give you the minimum value when we add the area of square and triangle. So x was 80 root 3 by 9 plus 4 root 3. When you subtract this from 20 minus 8 root 3 by 9 plus 4 root 3, y is going to be 180 divided by 9 plus 4 root 3. This is your x and y. Once you get this x and y, this is the final value. So this is the actual solution which is in front of you. It may take some time, because whenever root comes, there can be some mistakes that you can commit. But I hope that this is quite clear to you. This we will take in the later discussion. Thank you so much.